Okay, this is the last lecture for our MIS310 course, and it will be mostly about concepts and an assortment of concepts. Really, it's not just one. So it's a collection of little more advanced topics, and we'll be having a conceptual discussion. So before we do that, let's just take stock of what we have covered in the course so far, which is much more technical and hands-on. So let me pick up the pen here. So I think I mentioned in the very first class for the semester that there were three major components. One is relational theory, relational database theory, and in that topic you learn very basic concepts of what a relational database is. In other words, things like what is a relation, what does it take for a table to be a relation, concepts of primary keys, foreign keys, attributes, and then your entity integrity rule, referential integrity rule, all those things. So theoretical concepts behind relational databases, and we also discuss the concept of normalization, which has to do with taking care of various anomalies, update, insert, and delete anomalies in databases. So those were theoretical concepts. And then we spent a good bit of time on SQL. It's a language that's used to interact with relational databases, in other words, to create and manipulate relational databases. It was fairly precise, means it's a computer language, so it has a very specific grammar, and we spent a fair amount of time on the grammar. And then after we studied SQL, we studied the topic of database design. B-A-S-E, design. And under that, there were two sort of subtopics. One was conceptual modeling, which was the harder part. And under conceptual modeling, we looked at how to take the description of a business, how a business operates, its rules, its reports, its queries, screens, and all those kinds of things. And then from that, work out the structure of the database in terms of entities and relationships. And we ended up with something called the ER diagram. And then the second part to database design was the relational database design. Relational database design, sometimes also called the logical model, so conceptual modeling and logical modeling. And here all you're doing is you're taking the ER model and you're converting it to relations. And all kinds of details like primary keys, foreign keys, data types, whether something should be null or not null, all those kinds of things details are specified. Now if you look at these topics, you can see that they're fairly precise, and they deal more with how to do certain things. And again, since this is an introductory course, these topics are absolutely bread and butter. You must know these for any kind of database activity that you might do later on at work. So this is absolutely fundamental. Okay, but for today's lecture, what we are going to do is just discuss a few additional, more advanced topics, and we'll have a conceptual discussion. So let me move to the next slide here that has the list of the topics. So let me just briefly tell you what these topics are, and these sort of give you a feel for the kinds of topics that you might be discussing in a slightly more advanced course. Let's say you took MIS310 after 310, then some of these topics you would cover in that course, not all of them. And then later on, there are other additional electives courses, or if you took courses on your own and you took a career down the database path, then these are some of these topics that would sort of give you the foundation for moving forward in this particular domain. So if you look at this list of topics here, there are really sort of three main things. One is database administration. The other is concurrency, and the third is database security. So there are three major topics here, and these other topics that you find, ACID, indexes, views, these are related to the other three. Okay, so just to keep our roadmap straight for today's class, it would be helpful to think of these topics organized in this particular way. So we'll start with database administration. All right. So again, if you think back to the topics that we have covered so far, so with the exception of SQL has to do with extracting information from a database by most of it. You can also create databases using SQL. Of course, we've seen that, the data definition language. But if you think about the life cycle of a database, okay, so from birth to death, so a database, birth meaning you actually conceive of creating a database. So let's say a business is running things manually on pencil and paper, and then at some point they said this is getting too big, we are too inefficient, we need to implement a relational database. So that's the birth of the database, when its concept is born, like, hey, the need is recognized, we need to have a relational database. Then you spend a little bit of time. Again, in terms of the life cycle, a database can be in operation for years and years. So a certain amount of time is spent in collecting the requirements for the database. What do you need to put into the database? And then you do your conceptual design, then your logical design, and then you implement the database. You actually buy a piece of software, you buy a piece of hardware or many machines, and you install your database on it. So at this point, your database is operational. And the concept that we have learned so far, the database design, the ER modeling, the conversion to relational database, that's really covers this initial portion, the database design and implementation. So at this point here in its lifespan, imagine, I'm just simplifying the picture a little bit. You have created the database, you have put information in it, and it's operational, and you hand it over to end users, okay, to the organization that will actually use it. The rest of the life cycle of the database is its operational lifetime. It's actually being used. So if you think of the entire lifespan of the database, this development part might take, let's say for a large organization, I'm just throwing out a number, a year, let's say, or at least several months to design and implement the database, test it that it's working properly. And then it might be in operation for 5 years, 10 years. So clearly the operational phase is much longer than the development phase. At least you hope it is, okay? Now, during the operational phase, a lot of things have to happen in order for the database to work well and actually do its job for the business, okay? So I'll give you a few examples. One thing you want to make sure is that nobody unauthorized gets into the database. That's where database security comes in. You must enforce security, okay? Another major activity, you want to make sure that, let's say 100 users are going to work with the database, they only have access to the relevant portions of the database while it's in operation, okay? So your doctors, for example, shouldn't have access to your billing information in the hospital. The people who are in accounts should not have access to your medical information in a hospital. So there are access constraints, even though you can have 50 or 100 users or even more, thousands of users working with the database. Each has its own rights in terms of what they can get access to, okay? So obviously you have to maintain those kinds of constraints as well. So another major activity that you have to take care of during operation of the database is recovery and restoration, okay? So because it's a fact in life that things fail. So if your database crashes, how do you recover from the crash and bring it back up online? So you can think of a whole host of activities that go on during the operational phase. And those collection of activities fall under database administration. So you're administering the database. It consists of a whole host of activities, okay? So you can think of it as a managerial activity, which has various technical components to it. So under database administration, we will take a closer look at what are some of the activities that fall under that category. Okay, let me have a little sip of tea here. All right. So another major technical issue that one has to worry about during operational phase of the database is that it's almost never the case that one person works with the database. All practical databases, whether it's a hospital database, an airline database, a hotel database, a database for a university, any practical database that you can think of that an organization runs on, it will be used by hundreds of users and at the same time. Okay, so there's a lot of simultaneous users working on the database. In fact, I cannot think of a practical database where you don't have hundreds of simultaneous users. Okay, whether it's Hertz, Avis, United Airlines, American Airlines, Marriott, what have you. I can't think of a single Home Depot, Walmart. I cannot think of a single business database where there aren't hundreds of users simultaneously trying to use the database. Now, anytime you have simultaneous users, there is an issue that you have to be very careful about, and that's what's called concurrency. If you don't handle things just right, and this is a very technical issue, if you don't handle concurrency properly, then you can get very bad results. I mean, bad means completely wrong results. By bad, I just don't mean slow. And the system doesn't just slow. It's not a question of the system slowing down. It's the question of a system having incorrect results because of people working on the database simultaneously. So when we talk about these two topics, ACID and concurrency, that's the issue that we're dealing with. What kind of techniques are available to us to make sure that when hundreds of users are simultaneously using the database, you don't end up with erroneous and inconsistent information in the database. Okay. Now, so views, we will discuss. Views is a technique that's used to achieve database security. So we will see what that consists of. This last topic that I haven't mentioned yet is indexes. That has to do with speed of operation, the speed of access. So most commercial databases, most practical databases are extremely large. They're very large databases. You're not talking megabytes or gigabytes. You're talking 10 to the 12, 10 to the 15 bytes. Huge databases, and indexes are a technique that can be used to speed up access to the database. So just because the database is large, an end user will not be willing to wait several minutes to get the information that they need. They always want the information quickly, and indexes are one of the mechanisms that are available to you to speed up retrieval from a database. So we'll have a look at what indexes consists of. So that is an overview of what this last lecture is all about. Let me pause this particular video now because I see that I've run into 13 minutes. I try to keep these videos in reasonable chunks. So I will pause this recording right now, and I'll terminate this recording right now, and I'll start a fresh one to continue with this topic.